Jesus, I'm so sorry. My mic was muted. Can you hear me now? Oh my God. Oh my God. Oh my God. Wow. But do you understand what I did? Do you understand what I did with regards the question? So I make this arrangement, upper fixed point, lower fixed point, upper fixed point, lower fixed point. And from the question they said for 60 degrees. Okay, okay, that's great. So sorry about that. Yeah. Okay, so I think we can move to question 24 like that. And sorry, 54 like that. So for question 54, we have that. So in Roman figure 1, oh, okay. So if you read the question says that the the thermometer is found to indicate negative 0.5 degrees Celsius at the lower fixed point, and it indicated 100.5 degrees Celsius at the upper fixed point. Then they want us to find what it will indicate when the normal reading is 60 degrees Celsius. In a normal thermometer, the upper fixed point should be 100 degrees Celsius, while the lower fixed point should be 0 degree Celsius. Now, setting up this table now, this is what you always do. Upper fixed point will be at the top, lower fixed point will be at the bottom. Now they want us to find the reading when the normal reading of the temperature is 60 degrees Celsius. That means that whatever that thermometer, whatever it will read, let me call it X. So if I call that whatever it will read, if I call it X, so I'm going to use this approach. Basically what we are doing is that we'll be subtracting the lower fixed point from the two guys that are up. So that is why in the first case, in my numerator, I did 100.5 minus this guy down here is minus 0.5, then over x, which is also a guy in the middle, subtracting negative 0.5 from it. So we have x minus negative 0.5. Then you do the same thing on the right hand side as well. So that will be 100 minus 0. 0 is the lower fixed point. Then you also do 60 minus 0. So that will be this. Then, so I got the fraction now. So you see this negative times negative sign will become positive. So if you add them together, you add 100.5 plus 0.5, that will give us 101. And this negative times negative sign will give us positive sign. So you have x plus 0.5. Then 100 minus 0, this will be 100 over, this is me just cutting. And then when you cut, you cross multiply. Then from there, you solve for x. So x is 60.1 degrees Celsius. So is it clear now? What I did there, is it clear now? Please let me know if what I did is clear now. Okay, very good. Please alert your other guys, because I don't know why only two people are in this class. The other guys are not. Okay, so let's move on. 54. In question 54, Roman figure 1 says that a body is falling from a height of from rest. A bus fall from rest to the ground in 0.5 seconds. So time taken to reach the ground is 0.5 seconds. So for us to calculate this, so we are looking for the height. Using the equation h equals ut plus half gt squared. If we use this equation, what we'll have is, in this place, since it's falling from rest, that means that the u will be 0 meters per second, since it is falling from rest. So our h will then be 0 times 0.5 plus 1 over 2. Our g is 10 times 0.5 raised to power 2. So this part will be 0. So that means that h will be 2 can go in 10, that's 5. Then 0.5 squared, that should be 0.25. Then when you do 5 times 0.25, you get so you get 1.25. So the correct answer to that one is 1.25 meters. That's the height it fell from. Now for Roman figure 2, what we have is we were given a simple pendulum, and then mass is vibrating there at the end of the spring. We have to look for the spring constant. So in this situation now, we have to use the fact that period equals 2 pi square root of. Now, in case you you forget easily, just know that for a simple harmonic motion, if you are dealing with helical spring, just know that in this place, the general equation of simple harmonic motion is A equals minus omega square x. And from what's it called? From this law, Hooke's law, we know that F equals what? F equals minus KE. So that implies that F, which is MA, equals minus KE. Though our E will be our X in this place. So that means that if I solve for A in this place, A will be minus K over M times X, where X is also the extension. Please take note of that. So when you compare both equation now, I mean when you compare this guy and this, so you notice that W square is with X here, K over M is with X here. So that means that W square equals to what? K over M. And you can get that your W will be square root of K over M, where W, omega, this is actually omega, is the angular frequency of that body in simple harmonic motion. So with this now, we know that period is 2 pi over omega. This is a standard thing that you should know. Period is 2 pi over omega, and that means that we'll divide this 2 pi with square root of K over M. Then M will come up and K will come down. So that is in case you forget in the exam hall. So from this question now, we already have the period, which is 1.7, and this is 2 pi square root of, we already have the mass as well. The mass was given to be 50 grams. You must convert your 50 grams to kilogram. So that will be what? 50 divided by 1000. So, and that will give us 0. So that will be 0.05 over the spring constant that we are actually looking for. So when you solve this very well, you can have 1.7 over 2 pi equals square root of 0.05 over K. Then you square both sides. Then at the end of the day, if you solve this, I believe you should be able to make this thing solve the formula. So if you solve this, you have 1.7 divided by 2 pi. Then you square the answer. Then after squaring it, you then have 0.05 divided by the final answer. So the spring constant here is 0.683 newtons per meter. So let's look at that. So the correct answer to that question is, so they are asking us that for Roman figure 1, they are asking us the height with which this thing fell from. And for Roman figure 2, they are asking us for the spring constant. Okay, you don't make any error. Okay, we're given pi to be 3.142. So let's look at that again. Period is 1.7 over 2 times 3.142. So I'm applying. So if you are also with me, you can also try to solve this particular equation like that. So you square both sides. Once you square both sides, then you have 0.05 divided by this answer. Okay, still the same thing. So the correct answer in that place, this is approximately 0.7. Approximately 0.7 newtons per meter. So we got our height that was falling from as 1.5. We got that height as 1.25. So, and then we got this one as 0.7. So I guess there's an error in the way the answer was typed. So the correct answer there should be D. So there's an error in the way the question was typed. So the correct answer there should be D. So do you understand the whole process? So just remember this formula when you are in the exam hall. Just remember this formula. T equals to 2 pi square root of m over k. That is the formula to be used when you are dealing with a simple harmonic motion that involves helical spring. Okay, straight to question 55 like that. Straight to question 55. A ball of mass 500 gram falls from a height of 10 meters onto a hard floor and rebounds to a height of 7 meters. What energy is lost by the ball due to the impact on the floor? So initially the ball was somewhere around here, and then it falls, according to the question, it falls from a height of 10 meters. So if the height is 10 meters, then the ball is of mass 500 grams. This is the same thing as 0.5 kg. So that means that it was initially at rest. Total energy initially is going to be mgh. So mgh, which will be the potential energy, 0.5 times 10 times height, which is 10, and that would be what? 50 joules. Then when it came to the ground, when the ball got to the ground, it bounces up, but it couldn't reach the same height where it was coming from again. It only bounces up 7 meters. So if it only bounces up 7 meters, that means that total energy at this new level now will also still be mgh, but the mass still remains 0.5, g still remains g, but the height is now 7. So with this now we have 35 joules. Hence, the amount of energy that it lost will be 50 minus 35, and that will be 15 joules of energy. So you must have lost 15 joules of energy. Let's move to question 56. Question 56, we have a block and tackle system are used to lift a load of 30 newtons through a vertical height of 15 meters. If the efficiency of the system is 60%, how much work is done against friction? So block and tackle system, they use it to rate a load of 30 newtons through a vertical height of 15 meters. So in this place, we'll be using the fact that efficiency is work output over work input times 100%. Now, so in this particular situation, work output is the work that is done to raise that guy. So work output is the work that is done by the load, which is going to be load times distance moved by the load. So don't forget, work done is force times distance. So work output is done on the load. So that means that the value of the load multiplied by the what? The distance moved by the load. That will give us the work done, which is the work output. So that was 30 newtons and 15 meters. So 30 times 15. So 30 times 15 should give us 450. So that's 450 joules. Now, you see, for internal work done, work input is always, now, whenever friction is involved, that will be the sum of the work output plus work done in overcoming friction. So that would be work output plus work done in overcoming friction, and that will be what? 450 joules plus whatever work was done to overcome friction. So whenever there is frictional force in a system, so this will be the work input, so the work that you could see and the work that was done against friction. So now, to apply that, now we have been given efficiency at 60%. So this basically implies that 60 equals work output, which is 450, over 450 plus, let me just call that one W, times 100%. So in that case now, we need to solve for W in this place. So we know that from this whole thing now, this will be, so 60%, the percentage can cancel out, then we'll have what? This implies that 60 multiplied by 450, that thing that is in bracket, 450 plus W equals 450 times 100. So that will be 45,000, like that. Okay, so from this place, one of these zeros can cancel out here. So you can use 6 to open the bracket. So we have 6 times 450. That's 2,700. So that implies that 2,700 plus 6 times the weight will be equal to 4,500. And that basically implies that 6 times 6W equals 4,500 minus 2,700. So that implies that 6W equals, so 4,500 minus 2,700 is 1,800. So that means that W is, since 6 goes in 18, that's 3. So W is 300 newtons. So work done in overcoming friction will then be 300 newtons, like that. So it will be 300 newtons. Okay. So that is that was question 50. Sorry, work done is in joules. Work done is in joules. 300 joules. So which question did I just finish now? That was question 56. So going to question 57 now. Please, once I do anything and you don't get, please call my attention to it. The reason why I'm not doing like I did the first day anymore is because we don't have a lot of time and your exam starts on Thursday. So we need to finish as much as we can in the short period of time that we have. Okay, so 57 now. The motion of a particle is described using that equation. So the equation is x equals 2t raised to power 4 minus 3t raised to power 3. 2t raised to power 4 minus 3t raised to power. So we're looking for the velocity and acceleration at the time t equals to 2 seconds. So velocity will be the derivative of x with respect to t. And to find derivative, what we do is that we multiply the power with what is behind, and we subtract 1 from the power. So when you do that, you have 4 times 2 is 8. Then you subtract 1 from 4, that will give you 3. Minus, if you do the same thing with this, 3 times 3 is 9. Then you subtract 1 from the power, you have t squared. So that implies that at t equals to 2, our velocity will then be 8, 2 raised to power 3 minus 9, 2 raised to power 2. So this will be 64 minus 36. So 64 minus 36, that would be 28. So that would be 28. So the velocity is 28 meters per second. So let's find the acceleration. Acceleration is the double differentiation, second derivative of that guy. So that means that we differentiate this thing again. 3 times 8 is 24. Then t raised to power what? 2, like that, because you do 3 minus 1. Then minus 2 times 9 is 18. Then you subtract 1 from this place. Now at t equals 2, so that means that acceleration will then be 24 times 2 squared minus 18 times 2. So if we go through that, we'll have 24 times 2 squared, then minus 18 times 2. So when you do that very well, you have 60 meters per second squared. 60 meters per second squared. So the correct answer in this place is 28 meters per second, comma, then 60 meters per second squared, respectively. So the correct answer there is A. The correct answer there is A. The correct answer there is A. Okay, I think I can move to question 58. So to question 58 like that. So in question 58, we have, which of the following is false, rather. That is, which of the following is not true? It says that A, the first type of lever has a pivot between. So to know the different types of lever that we have, this is what we always do. we always use the term flare. Flare. So you always use flare. Now this flare signifies that this is the first class, this is the second class, and this is the third class lever. So first class, second class, and the third class lever. So with this now, we have, so let's now use that to answer the question. So question 58 says that which of the following is false? The first type of lever has a pivot between the load and the effort. Yes, that's correct. F is the fulcrum, the pivot. This F is the fulcrum, L is the load, E is the effort. So Roman figure 1 is correct. Sorry, A is correct because the fulcrum is in the middle for the first type of lever. So B, option B now says that a scissors is an example of the third type of lever. No, that is wrong. A scissors is an example of the first class of lever. So that means that the correct option is B, because that is the one that is wrong. A scissors is a first class lever. A scissors is a first class lever. 59. A fundamental, so question 59, a fundamental standing wave was set up in a tube of length 80 centimeters with ends open. So take the speed of sound to be that. What is the frequency of the second harmonics of the wave? Now, for the second harmonics now, for this guy, open pipe sort of behave like a stretched a string. So this is what an open pipe look like. So one thing you should know is that whenever you have an opening, the opening always find an antinode with it. So you have this, then you have this, then to go to the second harmonics like that, so it has to go like this. So this is the second harmonic, this is the second harmonic. So let's see the way it goes. So for the second harmonic, we have, I think I've made this to be too big, so let me reduce it. Okay, so this is the second harmonic. So now let's look at what the length of this thing will look like in this second harmonic. So what happened here is that this, from this place to this place, is lambda over 4. So from this place to this place, lambda over 4. From this place to this place, another lambda over 4. And from this center to this place, you have another lambda over 4. And from this place to this place, you have another lambda over 4, making 4 lambda over 4. So the length is 4 times lambda over 4, which means that the length equals lambda in this place for the second harmonic. L equals lambda. And from what we know already now, that L equals to lambda, then we can get every other information that we need. So from that place, we have question 59. So length is 80 centimeters. The length was 80 centimeters. So we can now get our lambda now. Our lambda is 80 centimeters, which is the same thing as 0.8 meter, because you have to convert that to meter. So we have our wavelength. So using the formula V equals F lambda, that implies that frequency, which is what the question asks us to look for, will be equal to V over lambda, and our V is 343. V is 343 and this is 0.8. So let's do that division. So if I just join in, I'm doing question 59. Question 59. So our V was given as 343. So divided by 0.8. So that gives 428.75. 428.75. So the frequency is 428.75 hertz. 428.75 hertz. Okay, let's go at question 60. Two bodies A and B of masses 10 kg and 4 kg move towards each other with velocity of this and this respectively, and they collide with each other. If the collision is perfectly inelastic, calculate the loss in kinetic energy. So basically that means that they move together after collision. So let's first of all calculate their common velocity first. When we get their common velocity, then we can find the loss in energy. For the first mass, which is 10 kg, moving in this direction, that 10 kg mass was moving with 6 meters per second. Then coming on the other end, we have another mass. That particular mass was 4 kg and it was moving towards each other. That one was moving at the rate of, so question 60 is what we are doing, at the rate of 3 meters per second. So we know that momentum will be conserved. So the total momentum before collision will be what? Total momentum after collision. Total momentum before collision will be 10 multiplied by 6 minus 4 multiplied by 3. And since they stick together after the collision, that means that they will have a common velocity. So you must add the two masses and multiply by a common velocity. So this will be 60 minus 12 equals 14v. And that means that v will be equals to 60 minus 12, that's 48. So 48 over 14, which will be 14 over 14 is 3.43, approximately 3.43. So now that we have the velocity that we need, we have the speed. So let's calculate the total initial kinetic energy. Total initial energy, that will be half m1 v1 squared plus half m2 v2 squared, and that will be equal to, so this will be 0.5 is half, so m1 is 10 times 6 squared plus 4 times 3 squared. So I'm applying that formula now. So this will be 0.5 into bracket. So 6 squared is 36. So that will be 360 plus 3 squared is 9. That will be 36. And this will be 0.5 multiplied by 360 plus 36. 360 plus 36 is 396. So when you multiply that by 0.5, you have 198 joules. So total initial energy is 198 joules. Now, after it had undergone that collision, total final energy will be 1 over 2. This time around, they are moving together with a combined force of 14, combined mass of 14 rather, and we have been able to get the velocity with which they move apart. That's 3.43 squared, and this will be 3.43 squared times 14 over 2, like that. So this is approximately 82.35 joules. So hence the loss in energy will be 198 minus 82.35. So 198 minus this will then give us approximately 115.65 joules. So that is the amount of energy that was lost in the process, 115.65 joules. Okay, to question 61. If you have missed any part of this thing, you will have to watch the video again, because I don't know why most of us are not very active and always join the class when it has been stipulated. So same thing happened yesterday, so I decided not to wait today and continue. Okay, 61. We have a linear expansivity. What temperature rise would cause it to increase by 1 over 10 of its original length? So one thing you know about this thing is that we know that change in L equals, so first of all, coefficient of linear expansivity is change in L over original length multiplied by change in theta. That means that change in L equals alpha original length times change in theta. So the question is asking us that what will be the temperature change? What will be the temperature change? What temperature rise? Which means that what we are looking for is change in theta. So I don't even need to tamper with this because it is asking for temperature rise. So with that, what is this thing going to do? What temperature rise would cause it to increase by 1/10 of its original length? So if it will increase by 1/10 of the original length, so that means that that is your change in length you have been given already. So your change in length, according to what we have been given now, is 1/10 L original. 1/10 L original. And we have been given alpha in the question. Alpha was given as, so that is 1, 2, 3, 4. 2 times 10 raised to power minus 4. 2 times 10 raised to power minus 4 per Kelvin. So substituting that into this place, that means that 2 times 10 to the negative 4 equals, no, that is change in L is, change in L will be 1/10 L naught equals 2 times 10 to the negative 4 multiplied by L naught multiplied by change in theta. So in this place, what you notice is that L naught can cancel out. Then change in theta, which is what we are looking for, will then be change in theta, which is what we are looking for, will then be 1/10 divided by that. So divided by 2 times 10 to the negative 4, which is the same thing as change in theta is 1/10 multiplied by 1/2 times 10 raised to power negative 4. So when you do this very well, you will have 1/20. So that will be 0.5 times 10 raised to power negative 3. So which will be what? 5 times 10 raised to power 2. So when you do this very well, you will get 5 times 10 raised to power 2 Kelvin. So the rise in temperature will be around 500 Kelvin. 500 Kelvin. So, okay, since they are putting it in 0.5, so if 0.5 should go to the back, that will be times 10 raised to power 3 Kelvin. So that is the correct answer to that. Okay, for question 62. For question 62, we have a certain mass of air is trapped into the sealed end of a narrow tube of uniform bore by a thread of 15 centimeters long. When the tube is held vertically with the closed end at the bottom. So let's look at the analysis for the first case. Certain mass of air is trapped into narrow sealed of a sealed end of a narrow tube of uniform bore by a thread of mercury 15 centimeter long. So when the tube is held vertically with the closed end at the bottom, so this is the shape of what that will look like. So the closed end is at the bottom. Then there is a shape of, so mercury thread was trapped here. We know that this mercury thread is 15 centimeters long. So with this now, we now have that, so according to the information that we're given there, they said that when it was held in this manner, the air column is 10 centimeters long. The air column is 10 centimeters long. So this is where we have the air, 10 centimeters long. So this is where the air is. So they continue further to say that the atmospheric pressure and the length of the air column when the tube is held horizontally are respectively. So we are looking for the atmospheric pressure and the length of the air column when the tube is held horizontally. So basically, to solve this problem, so we have this tube is now held horizontally. Let me extend this a little. So I think I'm going to need to draw another one. Yeah, so when it's head horizontally, this our mercury trend will still remains the same. Mercury trend will still remain the same. So it is still 15 centimeters. Now, they want us to find the length of the air column at this point. The length of the air column. So air is air. Now, this is the way it works. Whenever you are dealing with questions like this, open end is always the atmospheric end. Please take note. Open end is always the atmospheric end. So permit me to do in this place that the atmospheric pressure will be denoted using capital letter H, and the gauge pressure will be denoted using small letter h. So in the first case now, from what I taught you yesterday, I told you that total pressure is always, so total pressure is going to be atmospheric pressure plus or minus the gauge pressure. And I told you that if you are going down, that is when you use plus, and if you are going up, that is when you use negative. So I've already explained that yesterday. So in this situation now, since the atmospheric level always correspond with the open end, so this guy is open air, so this is the atmospheric level. Where do you notice that the air is now? The air is down inside the column. So since we are going down, that means that total pressure for this left hand side limb, so let me label this one for the left hand side. So the total pressure in that place will be the big H plus the small h, will be the big H plus the small h. And after getting that, so the small h is actually this length of the mercury column. Please take note of that, because that's how much distance you need to travel down before you reach the air. So that is that. Now for this second place, now for the right hand side, so let's do the same analysis. In this place, you notice that the atmospheric level is here, but there is nothing in this place that is not going down, is not going up. That means that the place where the air is at the same level with the atmospheric pressure. So that means that the total pressure in this place is going to also be what? Purely the atmospheric pressure. Now we're not done, because we're going to be using Boyle's law for this. Now what about volume? Volume, we don't need to use, volume is like area times height. So in this case, we ignore the area, since the area will be the same thing. So we don't need the area, we only need the height. So height here is 10 centimeters. So we will use our volume as 10 centimeters. Don't forget what this H is, like I've told you already. This H is 15 centimeters. So then our volume in this place is what we are is one of those things that we do not know. Our volume in this place is one of those things that we do not know. Now from Boyle's law tells us that P1 V1 equals P2 V2. So the implication of that is that our P1 is H plus H, which is capital letter H plus 15, times the volume is 10. Then the P2 is this H, then the volume is length of the air column that we don't have. So in that place we have so let's look at the things that we have again. So when it is inverted, the air column is 15 centimeters long. Oh, there's another situation I have not analyzed. So there was 3 cases actually. So this time around, when it was inverted, so that same guy was inverted. So let's do the analysis again for the inverted part. Okay, so in this inverted part, we'll have something of this nature. So please let me know if you are following what I'm doing though, because initially I assumed that nobody was here, so I was just doing it so that when you guys come around, you can just view the video instead of being around. Please, is anybody following what I'm doing? Please. So for this particular place, our age still remain 15 centimeters. Then this, according to the question, this was given as 15 centimeters. So in that case, okay, thank you very much. So in this case now, so I think I should call this one middle now. I should call this one middle because I've introduced another guy in it. So this is middle. So let me do for the guy on the right like that. On the right, in this case now, total pressure will be H minus H. According to what I said, this is the atmospheric level. It's always the open place. When you are going up, it will be minus. So this will be H minus 15. Then the volume, according to what we have been given now, the volume in this place is also 15. So with this equation now, I can equate any of these P1 V1 equals to P2 V2. So I think what makes sense for me to do is to first of all equate the left hand side to the right hand side. So let me bring this down. So the left hand side, using Boyle's law, P1 V1, so equals to P2 V2. So I've done my P1 V1, P2 V2. So the new P there is what? H minus 15, and the volume is 15. So with this now, I can calculate what my H is, knowing that this will be 10H plus 150 equals 15H minus 225. Yes, let me confirm that. 15 squared equals 225. When you do the whole collecting of like terms, so you have 150 plus 225 equals 15H minus 10H. So this will be, I think this will be 375 equals 5H. So that implies that H will be 375 over 5. So 375 over 5. So that's 75 centimeters. So the atmospheric level pressure will be 75 centimeters. So now let me proceed to go and get what my length of air column is for the slant guy. So what I will just do is that I will equate this one again. So using P1 V1 equals, so using P1, so let me call it P1 V1 equals P3 V3, where 3 is the third case. So this would imply that, so my P1 is H plus 15, then my volume was 10, H times the volume, which is the length of the air column in the second case that I'm looking for. In this place, I've been able to get my H. My H is 75. So 75 plus 15, that will be 90. 90 times 10 equals 75 times L. So that implies that L equals 900 over 75. And that would imply that L equals 900 divided by 75, which is 12 centimeters. So the answer to that question, they said we should look for the atmospheric pressure. So that was 62. Look for the atmospheric pressure and the length in the air column. So that will be 75 centimeters mercury and 12 centimeters respectively. And that gives the answer to that particular question. Okay. 63. A girl is standing 2 meters in front of a mirror. The girl is standing 2 meters in front of a plane mirror and decides to move backwards at a speed of 4 centimeters per second. What is the distance between her and the image 5 seconds after. So let's say this is the mirror. Then the girl is standing 2 meters away from the mirror. So this girl is standing 2 meters away in front of the mirror. So what this girl needs to do is that, according to the question, oh, thank you, thank you, thank you. So according to the chemistry tutor, thank you, welcome. So according to this now, the distance from the mirror is 2 meters. Then we have these 2 meters here like this. So this person wants to move back at the rate of 4 meters per second in the next 5 seconds. So first of all, the velocity with which they are moving back, is we are on question, please, those of you that you will be watching this later, we are on question 63. So question 63, the speed that was given is 4 centimeters per second. And those of you that are just joining, please, we are on question 63. I continued to record because this is the time that we fixed. So I continue to record knowing that you all can watch it later. I will send the video to you later. So that's why I just continued. So all of you ran away today. So anyways, let me continue. By the way, school does not always miss my class. I don't know why he is not around today. Somebody should help me look for school. He does not always miss my class. So please help me look for him. Now, okay, so let's continue. So what you need to do is that what? You need to get the new distance of this guy in front of the mirror. So since he's moving back as 4 centimeters per second at the rate of, and then he's doing that in 5 seconds. So 4 centimeters is the same thing as 0.04 meters per second. 0.04 meters per second. So the question says that, so if you read the question again, it says that the guy is standing 2 meters in front of a plane mirror, decide to move backward at a speed of 4 centimeters per second. So the question says that, what is the distance between her and the image 5 seconds after? So in this situation, you use that speed equals distance over time. So what distance would he have covered now? Then the distance is, so the speed is 4 and then the time will be 5. So according to this now, oh, so the speed is not 4, it's 0.0. The speed is 0.04. 0.04, and then so if you do this very well, 0.04 times 5, that will be 0.2. That will be 0.2 meters. So that means that the new distance of this girl now in front of the mirror will be 2.2 meters. Now, according to what we know, the distance of the object in front of the mirror will be the same as the distance of the object at the back of the mirror. So this place too will be 2.2 meters at the back of the mirror. So the image is formed at the back of the mirror. So the question is asking us that, what is the distance between her and her image? So that will definitely be what? 2.2 plus 2.2, which means that the total distance now will be 4.4 meters. 4.4 meters. So that's the answer to that question. Okay, the next one, 64. For question 64, we have that a ray of light undergoes minimum deviation when the incident angle is 30 degrees. So we have the incident angle here to be 30 degrees. Angle of incidence is 30 degrees. It undergoes minimum deviation. Now, from this place now, the refractive index N is given as 1.5. So the angle of minimum deviation, we are looking for angle of minimum deviation. So from what we know, actually, the refractive index is sine A plus D over 2 divided by sine A over 2, where A is the refracting angle. But in this particular question, we were not given the refracting angle. Since we're not given the refracting angle, so what we're going to do here is that we're going to need to find it. So let me show you what is going to happen. So when you have a prism here, the refracting angle is here at the top. So you have the refracting angle is here. Then you have the normal ray here. So this light is incident, let's say at an angle I. So as light is incident, it goes inside, refracted, then upon this place it emerges again. So then you have this, your angle made with the normal. Angle made with the normal is the new angle of refraction, and then this is the previous angle of refraction. So from this I and R, I was given to be 30 degrees. So here is the idea to be used. We can use the idea of triangle. If I complete this triangle, so what I can draw out is this shape. So let me draw the shape out so you see what the shape looks like. So up here I have A. Whatever this angle is, I can call it theta. So let me call this angle theta. So I can find this theta like this. So to find the theta, what I will do here is I will go and use Snell's law again. N equals sine I over sine R. So that will be sine 30 degrees over sine R. So 1.5 will be sine 30 degrees over sine R, like that. So from this place we have that sine R will be equal to sine 30 over 1.5. Sine 30 is 0.5, so divided by 1.5. 1.5 is 3 over 2. So divided by 3 over 2 means that multiply by 2 and divided by 3. And that will be 1 over 3, like that. So that means that R is the sine inverse of 1 over 3. So from there now, we look for the sine inverse of 1 over 3. Please, if you are still here, let me know. And you are following what I'm doing. Actually, the question, it was supposed to give us the value of the refracting angle. So all I'm doing now, in JAM, they will always give you value of the refracting angle. So all I'm doing now is just plenty mathematics. So let me know, those of you that are still here watching. Okay, cool. So now I've been able to get my angle of refraction. With my angle of refraction, unfortunately, there is nothing much I can do in this place because the information given in that question is not enough. Because as I've gotten my R now, I should be able to get the angle from this side, which will help me to get my theta. So the information given is not quite adequate. So I will look for the I will edit the question to a more suitable way, then you will get the solution in the next class. So let's proceed with so instead of wasting time on this, let's proceed with the one that we have full information. So 65. So please let me mark this particular question so that we'll go through it later. Okay, Shadow, is this your first time of joining, or have you joined any of the class before? Is this your first time of joining, or have you joined the class before? So the next question, question 65, says that find the thickness of a prism of refractive index 1.5 if the prism displacement of the object is 1.5 meters. If the prism displacement of the object is 1.5 meters. So in this place, to calculate the thickness of the prism, so we have the displacement already. Now, in this particular question now, so what we have to do is that we have to first of all calculate for, hello, oh, okay, okay, oh, no wonder, no wonder, that means that, so oh, very good, very good, very good. So that means that the people that are here on this live, I'm not sure you have the what's it called, the question I'm solving. Oh, I was sure wondering. This live class was supposed to be for some of my private students. Actually, it was supposed to be for them. So I forgot to make the live private, and I forgot to share the link with them. Yeah, 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 yeah. I get that. My class with you guys is actually tomorrow. My class with you guys is supposed to be tomorrow. This one is supposed to be for my actual private student as well. I've been solving some questions with them. So I didn't even notice that they are not on this live. I was just, solving the question. And as a matter of fact, I'm supposed to actually send the link to them. Oh my god, thank you for calling my attention. I will have to end this particular live and send the link and create another live to send the link to my students.